Okay? Our other one, and this is called our slope y-intercept, okay? So I'm going to call it slope y-intercept. That's one of them. The other one is standard, that's right. Does anyone remember the formula for standard?
O equals AX plus B, Y plus C.
Okay, it's not O, it's 0. That's good. 0 is equal to AX plus BY plus C. Now, each of these variables all stand for something. It's been a while since we've gone through this, so we'll quickly talk about it. What does the M stand for in the slope y-intercept? Slope. Stands for the slope. And what does the B stand for? The y-intercept. Perfect. The title literally tells you what they do. In this one, or in our standard, do we know what the A technically stands for, or the B?
No.
Not exact. How about the C?
No.
The C tells us something. Anyone know? It does help us out a little. Yeah, it gives us our y-intercept also. Okay? So, but more importantly, this one gives us a lot of information about graphing. And since we have a point and a slope, we're going to try to set up this equation. And then maybe after we'll change it into standard form. But this is the information we've given. They say m is equal to a half. What does m stand for? 0.5, but what does it stand for in terms of graphing an equation? Yeah, it's called the slope. Okay, so that's how much it's going to go up and down by. So, remember the slope is known as the rise over the run.
Oh, I remember that.
Okay, so what this is saying is we'd have to go up 1 and to the right 2 units if we were to graph this. So this is our slope, 1/2. And they've given us a coordinate. This coordinate, the x value is 1 and the y value is 5. So we need to find the equation of the line. Well, let's try to plug in all the information we have. We have y is equal to, that's right, mx plus b. Okay. We know what m is. M is our slope, so we can replace the m in the equation. Y is equal to 1/2 x still plus b. Do we know the y-intercept? They've only given us 2 pieces of information. No. But we know a point on the line. And a point on the line essentially tells us an x and a y value. Do we have a spot in this equation where we can plug in an x and a y value? Yeah, we have an x and a y. So we're going to replace those values and solve for b, which is the y-intercept. Once we solve for it, we'll be able to rewrite the equation in slope y-intercept form. So we're going to plug in. Our x is 1, so I'm going to replace x with the value of 1. And our y, I'll use a different color, red. Y is 5, so we're going to replace y with the number 5. So 5 is equal to 1/2 multiplied by 1 plus b. Okay, we'll keep that in green, I guess. So from there, what would I do first? Well, let's first equate this. What's 1 times a half? Yeah, it's a half. That's great. So 5 is equal to 1/2. I'm going to write this in black from now on. Plus b. I need to isolate b. Remember, we're trying to find our y-intercept. So how do we isolate b? What would we have to do? Yeah, move the 1/2 over. When I move it over, what would it become? Negative. So 5 subtract a half is equal to b. What is 5 subtract a half?
4.5.
4.5, 4.5, whoever you want to write it, right?
4.5.
You can write 4.5 or 4.5 is equal to b. Perfect. So if we were to write this in our y-intercept form, our equation reads y is equal to, remember our slope is a half, x, and
4.5.
yeah, you can put 4.5. You might want to put 9 over 2 if you're going to put it as a fraction. Or if you prefer using decimals, you can put it that way, 4.5. Okay, any of these are acceptable, but this is the equation of our line. Okay, so we have that. That's what we need to do. Next thing I'm going to look at, instead of, and if you want to know how to change it in the standard form, just go back and watch one of the videos on how to change slope y-intercept to standard. I'm going to work on a more difficult question. Okay, we've got a word question here. It says, it costs Travis $25 to take a taxi home. Okay. The distance is 10 kilometers, and he knows the variable cost of the taxi is $2 per kilometer. He wants to figure out the fixed cost. So when you get into a taxi, whether you travel nowhere, they already charge you an amount. Okay? But Travis doesn't remember the amount they charge. He does know that every kilometer he drove, though, they charged him another $2. Okay? So we have to build an equation. So, for instance, y equals mx plus b. We know this is a linear equation. But what we want to do is we want to assign some of the variables information. So for instance, our cost, our total cost of a taxi, that will be our y value, right? Because we got to think of independent variables. Depending on how far we drive, our cost increases. So our independent is our distance, and our dependent is our cost. So remember, independent is always our x. And our y is always our dependent variable. So let's rename these. Our distance we'll call d. Okay? So since our x was our distance in this case, we're going to replace x with the letter d. Maybe this will help us out a bit. If not, we can leave it the other way. But we still have our m. Our distance is d. Maybe that'll be too confusing. There's too many letters involved here. And our dependent variable was our cost. Okay? So we can call that maybe c. I'll give that a different color. Right now it looks really confusing. We have a whole bunch of letters here. And if you prefer to leave it in this version, that's fine. We'll do it two different ways. They're both the exact same. Okay? What was Travis's total cost to ride in the taxi? $25.
$5.
Okay? So remember, cost was our C, so we have 25. And that was our Y. That was our dependent. So we'll replace Y with 25. It still ends up being the same equation. Okay? Our M, what is our M in this case? Does anyone know? You're right. It's going to be 2 in this case because our variable, and I guess maybe we should define it first. We'll keep it as M in this case to start. Our X is our distance, okay, our D. We don't know what our distance is in this case, and we don't know what the y-intercept is. Okay? But we do know the slope. Oh, I lied, actually. Do we know the distance? I apologize. We do. How far was the distance? 10, that's right. So we can replace our distance, D or X, with 10. So 25 is equal to M times 10 plus B. Or in the other case, it's 25 is equal to M times 10. That's not a B. That's supposed to be a 10. Plus B. Okay. And finally, what is our slope? What's our variable cost? Our variable cost, okay? So depending on how many kilometers we drive, it costs us $2. So that's our slope. Our slope is 2. So 25 is equal to 2 times 10 plus B. Or in this case, 25 is equal to 2 times 10 plus B. Okay? Now we got the exact same equation. So whether you wanted to do it with all these variables or you preferred this version, it's the exact same thing. We went through the same process to get to where we are. Okay? So we'll combine it from this point on. These are now the exact same. So 25 is equal to 2 times 10 plus B. Oh, what's 2 times 10? That's right. 25 is equal to 20 plus B. What do I have to do to isolate for B?
25 minus 20.
That's right. 25 subtract 20 is equal to B. What is our B?
5.
5. So, what does that represent? That 5. No? Yeah, it represents a y-intercept, which is also our fixed cost. Right? If we were to quickly draw a rough sketch of this, okay? We drew a rough sketch. If I go, our cost is our y, and our distance is our x, right? If I were to go nowhere, and I just stepped in the taxi and got out, how much would it cost me? Yeah, I'd have to pay $5. So here's our y-intercept, our fixed cost at that point. And then from there, every kilometer I go, how much does the price increase by? $2, all right? So let's say this is 7, 9, 11. It constantly increases by $2 depending on how far we go. So our equation, y is equal to Our slope is 2, x, and our fixed cost, or our y-intercept, is 5. So we've now built our equation. Okay, on this side. We built our equation from the information we had. We plugged in a point, and we had the slope, and we found our y-intercept.